Hi, my name is Thibaut Dehape. I am the main creator of Peccary, at least the first version. And this is a demonstration slash tutorial on how to use the Shiny application of Peccary. It is in addition to this document. So basically, I want to keep that video the shortest as possible. So there will be much more detail in this document with a lot of screenshots and edge steps with details. So if something is not working on your project and you don't find the answer on the video, you might find it in this document. So when to launch the application, you just have to write Peccary app 3. You start and it launches the application. So then you generally want to create a project, work to store every datasets or analysis you perform. So to that you just have to here to input the pathway of the folder you want to create. So you go here. Okay, let's say I want to create it on my desktop, so I can click on here, copy, I paste, and then I want like a Peccary demo. So this has to be a pre-existing folder, and this is the name of the folder you want to create. So you create project and you say you create Peccary demo. You can create another one if you want. So it create and load the project. If I close and reopen the Shiny application, I will have to click on here and it will load directly these folders, and you can have a quick access to the previously open project to directly have the right path. And this is it. So then you want to add your datasets. So okay, so to add datasets, you just have to click there. Then you take your datasets. Let's say this one. I copy. I paste. The separator will be automatically guessed as the decimal. I click on add and I have my datasets. I can add another one if you want, like this one. So automatically it recognizes what is the X and the Y column if it is common label. If it does not guess it right, you can just like modify it manually. And then you can save modification. Here you can choose which datasets based on these numbers will be open by default when opening a project. So this is it. Your datasets are loaded, and then you can switch. So let's say you have this, you can switch from one dataset to another just with this fielded datasets box. And here you have many elements to just explore datasets. So in Dataset Explore, the idea is you can observe your real data. You can also do some modifications. So let's say I want to add a new column. I can write absolutely what I want here. So let's say mutate W2 square equal W2 for square. Click on go and I will have my W2 square. I can save the modification either virtually. If I click on here, I just had a copy of it, this modification. And if I click on here, I will even create a new file with the new datasets. And of course, you can have access to the new datasets here. So here it means that it's the same as the self-in.txt plus some additional code that you can find here, and here, well, it's a new file. Don't forget to save modification if you want to reuse it when you open the project. And anyway, so then what you want generally is to use, like to have statistical exploration, description of your data. So you want to like shorten your dataset to have only one row per ID. You can do it by this, So you say extract cov by ID. Click on go, and this is it. One row per ID, and it only kept the columns, but there is one row per ID. Then you can do your description. So let's say I want to analyze my W2 continuous and my those cat on curve here, and you will have, well, your basic population descriptions. You will have the code you need to write from scratch if you want in the R console, so with the specific function created by Peccary. Here is console count is when you have column with boolean, so 0, 1 or true or false. You let's say it's I don't know, like whether a patient is a good responder to a treatment. You can say bool, I want those cat and cov, and you will count how many patients out of how many is a good responder or is positive based on this boolean. And here you can have again the Peccary function that you will use in the console mode if you want to use Peccary in the console. Here is very new, and it's just a quick way to like see if there is correlation between two covariates. For instance, you just have to plot the covariates. So if I, well, let's take for instance, so let's just count maybe. So here, if you have only one plot, you have very basic histograms. If you give both a cat and a count covariate, you will have box plot with some statistical tests that you will be able to modify in the futures. If you give two categorical covariates, for instance, here you can have that, for instance. So this is it, and then you have the graphical exploration. So again, you can switch very easily from one dataset to another, or to the one you created just previously. And here is basically a ggplot on continuous covariate, continuous data, sorry. So here you have, let's say, I want to colorize by those cats, so you can colorize by what you want. You can do a wrap by ID. Well, it's really a ggplot, basically. You can choose your scale for the wrapping. Something I used a lot is much more when I have all patients in the background. So this is what I do when clicking on here. So here it's much more easier to compare one patient to all the other. And you have two filters, which is important. The first filter is applied in each data, both on the background and on the front. And the second filter is applied only on the front. So just to be clear, like if I say I want only to keep patient from 1 to 3, I keep only them both in the front, or in the colors, but also in the background. If I want every patient in the background, but only patient 1 and 3, I will do that. And here I kept all patients in the background, but only one patient if I want one patient. Very important, so you have the error code produced. So you have two types of error code. You have the function from Peccary, and you have the code that is produced by Peccary and then evaluated to produce the plot. So this is a code that is completely Peccary independent, and this is basically the ggplot you would have wrote from scratch if you made this plot from scratch. You have much more control here, so you will explore that by yourself, but if I want to change the colors, for instance, I can just say that blue and it's green blue. And most importantly, you can save the plot. So let's say I want to plot, I want ID 1. And then I will keep every patient, but I will wrap by, I don't know, those cat, for instance. And this is those cat. I can save it, and you see that you increment your table. Now let's close the project. Let's close the Shiny application and reopen it. So when you reopen the Shiny application, you have to first load the project. So you just have to wait. So this is demo 2. If I want demo 1, I can do that, but I want demo 2. I load the project. My datasets are still there. And when I go to graphical exploration, I can just click there, for instance, to re-have the same plot as previously, and here also. And I can perfectly change what I want after that. So it's a way to keep track of your plots and you can really modify them as you want. Okay, then you have the NCA. So for the NCA, you have two types of NCA. You have the NCA produced by Peccary and by the pknca. So for Peccary, basically I don't do any extrapolation. You can just have IUC TILA, Cmax, TILA, Tmax, and IUC 0 to, like, say, 28, for instance, if you want. You can analyze by covariates. So let's take, for continuous, you will have this, and you can choose which test you want to use. If you have now a categorical covariate, you can have that. If you want to force a continuous covariate to be as categorical, you can click on there. Well, many other elements, and you will have both individual values and statistical per curve. You can, and you also here have the short code of Peccary and the NCA analysis from scratch here. So this is it, and if you want to use the pknca package, mostly for extrapolation, you can do that. Let's say I want the scat, for instance. You can click on go, and you will have, well, individual and categorical values, and you will have the code that you will write to reproduce the analysis. So here the goal of Peccary is just to accelerate the use of the pknca packages by directly doing that, for instance. And you have much more control. The option of the pknca packages. You can click on there if you want to know what all these options are for. Okay, so far we saw how to load datasets and analyze them. Now we will see how to write or import a model and then make some simulation, design evaluation, and translation into various other syntax. The whole system is very highly inspired by the Markdown Pandoc system. So you know the systems allow you to write a document with the Markdown syntax, very simple and fast to type, and then by using Pandoc or knitting down Markdown, you will create some beautiful HTML. So this and this are the same thing, but I wrote it with a very simple syntax, and then I produce a much complex syntax document. The very high efficiency here only relies on the fact that the simplest syntax controls the most complex one. And this is what I try to reproduce in the pharmacometrics field. So I had to think, what's the most efficient way and fastest way to write a model? And the answer is, of course, just write the equation and nothing more. So let's take an example of very basic, like one compartment single elimination model. So you just have to write something like that. This central minus KE for central. And then you have your concentration, which is the central divided by VD. So, okay, so if you want to plot something that is not a compartment, you need to add plot here. So plot will be removed when doing the R analysis, but it just means that you want to plot the value concentration. So if you want to reuse concentration, you can say that, for instance, I don't know, and that will be the exact same thing. So you click on load model, and then an internal Peccary function just analyze what you wrote and say, okay, I found one compartment is compartment central, and you can choose what are the initial value. So that you can, so it's not only a value, it can be like a code, something like that, for instance. And here we found two parameters, so KE and VD, so we can assign them some value and some distribution, like normal, or no variability for now. And you have here the according variance covariance matrix coded in SD or in variance. And here is little complexified events table in relation to the dissolve packages, and this you don't really care about this one. So here I say, okay, at time 0, I inject in my central compartment like 50 milligrams, for instance. And this is it. So here you choose what you want to plot or to simulate. So let's say I want to observe both central and concentration. And I have this. They are the same, so let's put another video, otherwise preposterous. So you have both of, well, everything you wanted to display. So here you have, if you want to have this plot in logarithmic scale, and here is how you want to wrap. So here you don't have any wrap. Let's say you want to wrap by the output, so you will have one box per central and concentration. You can also add some points. So it will out the points that you have here. So as I want to have the points only on concentration, so you can do that. Okay, so you can say I want to go at up to 1030 by 01, for instance, and you will have that. You can remove, you can apply a filter. So for instance here I did not write absorption model, so we will just remove the first point. So we can do something like that, and you will remove the first point. So we have kind of intravenous data sets, we fake it at least, and here it. So then what you can do is try several values. So here it's not only one value, it's an error code that has to return an atomic vectors of values. So let's say you want to try several values, you can just write that. You write that and load plot, and well, you have one color code by values. So here actually to write by output, but I can also write by parameter values if I want. So here for each parameter values, you have that. So this is one way to try to find initial values. You can also try to make Peccary estimate the values for you. So let's start with a very preposterous value, something like that. We don't need central anymore. Load plot. So you see here you are very, very off, but you can try to estimate. And so it only use here basic naive pool estimation method based on the optim function of R, just trying to optimize the sum of the weighted residual. So here you think you see that it well, it finds some values that has been replaced here, 0.08 and 5, that allow you to capture well the data. So, well, again, you can try several values here. But you can also try several protocol administration. So here you see you have the protocol column. So let's have a second protocol. And let's say here you have, so here also it's an error code. So you want to have administration from time 0 to 48 every 12 hours, but only 10. And well, you want to wrap by events, and so here for each protocol, number 1 and number 2, you have all the 3 values of KE. And if you want the opposite, you can just say I want to wrap by parameter values. And for each parameter values, you will have your different protocol. So it's very flexible on what you can plot. You have another filter that I have to show you. So let's change your model and let's try to to do the Simeoni plot. So here I have tumor growth function plot, and I have some P data with 3 different doses. Right. So let's say I want to use that on my model building. So it's quite time consuming to write by scratch this model, so you can directly use the library input. So let's say I want one pk, one compartment coded in with clearance, and I was a Simeoni model, so it directly makes the link between the concentration and the PD. click on load model. So I already have some value prepared here. So here, just showing you, can do that. I copy, I pass the value. So here I need to have some values, initial values for my tumor. Let's say something like that. Okay, so let's see if it works. So I display only the tumor volumes. Perfect. I have in my dataset 3 protocols. So let's have 3 protocols. I have at time 0, either 0, 50, and 100. And let's add the point, but only for Y type equal 2. I don't need my other data. And I will plot it by events. So when I do that, you see by, okay, so you have to use the events. And we can go up to time 50. So when you see that, there is kind of an issue because all the points have been displayed on every event. So I need to have only my points of control, those 50 and those 100, and this is why this column is made for. So if I say those equal 50, so here also it's a error code. Sorry, those equal 0, and then you can do that, and here you have. If you want to not only plot the typical profile using the typical value here, but instead use simulations with the variance covariance matrix, you just have to put a number of simulation here superior to 0. So let's put 100 simulations and increase a little bit the steps to make it faster, and then you will perform the simulation. And very importantly, every time you make a plot here, you have a completely Peccary independent code that creates the plot here. So Peccary allows you to not write that. But if you want to modify the plot after that, then you can just copy that and paste it on the console mode and modify it on a script. So it makes that very efficient. And also you can of course save. So let's make something like that. You can save it, and then if I close and reopen the Shiny app and the project, I can just click on load, like let's remove that, click on load, and I will really have all the previous table that will be refilled. So I will really have exactly the same output. And so in my main project, I have like maybe 50 different model of prototype and things like that, and I can very efficiently switch from one prototype to another. The last thing is to you can import a model from Monolix or NONMEM, and it works best for the moment with Monolix. So basically, I have here a model on Monolix I just made. And you just can take the nlmixr file, and nlmixr file contains everything, the structural model, but also the datasets. So it will read the nlmixr file and every associated files. It will recreate the structural equation for dissolve/Peccary. It will give you the population parameters, and you can here change and choose any patient you want. Take this one. It will both give the exact input that the patient have, and also the exact individual parameter for this patient. And so now, just something that has to be improved in the futures, but I think it's 1 and 2. If you go by output here, okay, I should not make simulation. Let's put 0. If you do that, you have exactly the same individual profile that has been estimated by Monolix. And then if you want to see, okay, what would happen if I would have, like, let's say, this one multiplied by 2? Well, not two problems. Here you have what happened. Well, nothing. So by that, you can take any individual profile you want and see if modification of a parameter would have changed something. You can retry an estimation, you can change the tutorial model, and well, every time you change one patient, you will directly change the output like that. So this is very, very powerful, especially if you have a complex model and you want to see what kind of modification can especially improve a specific patient. And all other ways, you have the full code here. So this is it for creating a model, either from scratch with library input or importing a model from a Monolix or an NONMEM model. And then you can translate this in various different other syntax. So let's say I want to create a Monolix code. So I just read that and also table here, and I can reproduce the nlmixr file here. Well, the model file, but also the nlmixr file. What you can also do is create a NONMEM file. So entirely you will just need to modify the input or things like that, but then you have the whole structural equation. You can choose to code it in mu or without mu referencement. And you can also hide like the BLQ block, which will be here. And you can also have the adapt, but it's less performant. And same thing for the nlmixr, which should be improved. And then after, for the nlmixr, we might be able to directly launch and estimate from Peccary, and so we will have a complete open source whole system from econometrics. And well, a few other things, well, something very minor, but we can try to create the scheme of the model. So something like that, well, not very useful, but we never know. Okay, I just made a break, but I'm back. So the only thing that remains to be seen is optimal design for this part. So let's reload the Simeoni model that we did. We will just need, well, to add plot because this will be an observation. So the only thing that matters here is you see that you have 3 protocols and that will be used for optimal design. So let's say I observe concentration from group 1 who has the protocol number 2. What you have there is you can decide what parameters can be fixed or estimated. So if psi is already fixed, all the other ones are estimated. If, like, let's say psi0f, it means there is no variability and it's fixed, and this means the variability is fixed to 0.3, and we can also fix the error, both additive or proportional. Let's release the proportional error, so you do the eval design. So for the moment we don't do optimal design, we only do design evaluation. And it looks like that. So basically you have here the result. So generally you need to look at the console to see if there are some problems for inverting the matrix, which is the case. And of course here the pk parameters are well correctly estimated, but absolutely not the pd parameters, which is normal because we don't have any observation. So if we want to add observation, so same group protocol, and we can say, for instance, sequence 0 to 48 every 4 days, and we can also add, let's say, tumor volume will be also assessed in the group number 2, who has the protocol number 1, and the same thing, for instance, but it has NAD group is only 10. So you want to eval that, and let's see what will happen. So here is the result, and you see that you have well, correct estimation at least of the population parameters, but not necessarily on all, every omega. Well, of course, you have the whole code of Puppet. So this is basically where the goal and the objective of Peccary is to avoid you to write all that if you want to perform a Puppet analysis. So as I said, we don't do optimal design, we just do design evaluation. But in fact, it's not a real problem because in terms of efficiency, what was very expensive was to write all that. And performing optimal design based on that is very straightforward. So for instance, just copy that. You can quit, you can copy it. So as I said, if you want, we can remove everything. And this code will reproduce from scratch the design evaluation. Well, I will already have it here. And for instance, you can also see the Fisher information matrix. And so let's say you want to, let's say, add optimal design. I think it's here. You can add the discrete time from 0 to 50. I'd make some stupid optimal design, but just to show you. And then I think it's Puppet optim, I think. Okay, so it's that. PopDB. And you want to optimize the time, and normally it will work, so it will take some time, so we won't do it in totality, but you see it will just do the optimal design. Okay, so the last thing we need to do is run diagnostic. So model diagnostic and comparison, they are completely independent on the software you use, whether you use NONMEM, Monolix, Adapt, and nlmixr, it will be strictly the same steps. So you just first have to give the path of the folder which contain your runs, or several runs. So you just passed, you go, and then on the folder you will see, well, here he found 32 runs, so models from Monolix, NONMEM, nlmixr, or Adapt, and each run has a number. So if you want to see the results of a run, you just put the number of the run here. And if you want to compare some runs, you can just say, I want to compare run 1, 2, and 3, and we will have one column per run with a full join, so it will look like that. And well, as I said, it's independent of the software you use, which means you can compare, for instance, a Monolix with, I don't know, an Adapt if you want to see an Adapt code. Then what you can do is various plots, so we will go very quickly to see the plots. You have the prediction first, so you have individual predictions, and the thing is, if you provide several runs here, you will have one color per run, so you can easily see how they act. When you have growth, so for goodness of it plots, at first you only have the run number 1, even if it's say 1, 2, 3. But here you have the list of every growth that will be displayed when you click on multiple static. So the idea, for instance, is you can also, let's say, study ID. If I click on multiple static, I will have all of this plot, which is quite a lot, but then you can filter. So let's say you want every plot regarding only the covariate B, and you want, how to say that, like only one growth, for instance, because each growth has a number, so you want this plot, but for every run and only covariate B, you can do that, and then multiple static, and here you have it. So the idea is you can extract any covariate and any subgraph, especially, and compare them with different ones. So it's very agile, and if you really want to look at one specific graph, you can do it. For covariate, basically, it will be a box plot with covariate, and you will have one color per run. So let's just take one of those curve, and so you can see if there is an asymmetry, if it's corrected by adding a covariate or something like that. For the matrix, so it's the same as the growth, so it means by default in single you will have only the first one, so here's the one number 1, but you can extract really what you want. So this is what we will have for one run, and this is what it will display if you have the 3 runs, which might be quite long. So you can filter, let's say you want to look only at this plus specifically, so the name is clearance, so you can just say name equal clearance, and so you will see you will have only this 3 plots, you do multiple run, and you have this. So for individual lock likelihood, so if you say only one run, you will have that. So individual lock likelihood for each patient, and if you take 2 patients, it will make the difference between the two. So this first one minus another one is only useful when you look at a covariate, and sometimes if you see like there is a very high asymmetry, like all the one curve is here and one curve is here, you might have an asymmetry, and in fact you see that your model is just improving one subgroup and one other model is improving the other subgroup, which is always puzzling. But this is it. Sensitivity, you can forget it. Forest plot, so this is just a prototype, but you can fill a table like that, and then it will make a forest plot. And the thing is, if so, I need to know where I have covariate. I think this one is covariate, so number 9. If you do number 9, you can just pre-fill the table with your model and then click on go. So it's really like a prototype. Here it was a model where there was, well, not really a huge impact of a covariate. So it's a prototype, but it will, you can do that. So basically you will have the code allowing you to do that. So whether for Peccary or independent of Peccary, using the forest plot function of the covFXplots package. So here it's exactly like for the pknca or Puppet. The goal of Peccary is just to accelerate the production of the run. Final things is the VPC. So for VPC, you have ops, for instance. You have simulation, kind of prefill, you click on create VPC and it uses the VPC package, and of course you can see here the code for the VPC package. So one thing I forgot to say is when you have this, what you can do is just put the run number and click on all plots. So here it will take some time, so I will accelerate the video and see when it's finished. Okay, so this is finished, so it takes 1 minute 0.3, and so basically it creates you a PDF automatically where you first have your comparison between your runs, then you have for each runs you have a complete profile, so one looking at everything, and then second run, third run, and then you have a comparison of runs and, well, different ones. So it just allows you to create very so it takes time, but you can take a coffee while doing that, and, well, it's quite nice to have a very quick overview of all your run inside the same file and to share with colleagues. And again, it just takes you 3 seconds to just launch the creation. So I think this is it. There is some other stuff like the for instance, yeah, the report systems. I think we don't speak about that in this video, maybe another one. So if you have any questions, you can ask them. Peccary is a collaborative project, so if you want to participate in it, please do so. And that's it. So thank you for watching.